Good afternoon, my YouTube viewers. It's Crystal here. I wanted to make you a video about Excel, and what I wanted to show you how to do in Excel was how to cover independent and dependent events using Excel to make those calculations. In my last video, if you watched my last video, I performed calculations in Python. So now what I'm going to do is I'm going to take those exact same questions and I'm going to perform the calculations in Excel. So the first question we have is, it's independent events with replacement. Now, in independent events, the item that's taken out is replaced. And if you're asking for event A plus event B, it's going to be a multiplication. But if you ask for event A or event B, it's going to be addition. So those are some things that you need to know about independent events with replacement. So the first question we have is, suppose two cards are drawn from a standard deck of cards with replacement. What is the probability of both cards being diamonds? So you've got diamond 1, the probability is 13 over 52, which is 25%. Probability 2, diamond 2, is going to be 13 over 52, which is 25%. And the probability of both diamonds together, it's going to be probability diamond 1 times the probability diamond 2, which is going to be 6.25%. So that's your first question. So the second question is, suppose an experiment is conducted where a card is drawn from a standard deck of 52 cards and a fair coin is tossed. What is the probability that the outcome will be a king and a heads? So the probability of having a king is 4 divided by 52 because you've got 4 kings in a deck of cards. Probability of tossing a head is 50% because you either have heads or tails, and the probability of heads and tails is probability of the king times the probability of the head, which is 3.8462%. And then so now we're going to have the probability. Now we have another question. Suppose a family has 4 children. What is the probability that they are either all girls or all boys? So the number of children is 4. The number of boys is 50%. Probability of having a boy is 50% because you either have a boy or a girl. The probability of a girl is 50% because you have either a boy or a girl. The probability of all boys is probability of a boy to the power of 4 because that's the number of children. Probability of all girls is the probability of a girl to the power of 4, which is the number of children. And the probability of all boys or all girls is B24 plus B25. That's probability of all boys plus the probability of all girls, which is 12.5%. And the thing is, it's like if it's an or, it's an addition, and if it's an and, it's a multiplication. So the next question we have is, a fair die is rolled 2 times. Find the probability that both rolls will give even prime numbers. Okay, so there's only one even prime number in a 6-sided die, and that's 2. So the probability of row 1 being an even prime number is 1 divided by 6. The probability of the second row being an even prime number is 1 divided by 6 as well. The probability of both being an even prime number is row 1 times row 2, which is 2.7778%. So we have another question, which is an independent event with replacement. A bottle contains different colored candies: 12 red, 6 green, 8 pink, 4 blue. A candy is chosen from the bottle randomly. After replacement of the candy, a second candy is chosen. What is the probability of choosing 1 red and 1 blue candy? So a red is 12, green is 6, pink is 8, blue is 4. Total candies is 30 because it's red plus green plus pink plus blue. Probability of a red candy is red divided by total, which is 40%. Probability of a blue candy is blue divided by totals, which is 13.33%. Probability of red and blue, which is probability of red times probability of blue, which is 5.333%. So we have another question, which is an independent event with replacement. This is a true or false question, and it's false, but we're going to go ahead and go through it anyway. The 2 cards are chosen from a standard deck of cards with replacement. The probability that both cards is 1 divided by 52 is its false statement, but we'll go ahead and go through it. So the probability of the first ace is 4 divided by 52 because there's 4 aces in a deck of cards. Probability of the second ace is 4 divided by 52 because the previous ace was replaced, the previous card was replaced, and so that's why you got 4 over 52. The probability of both aces is ace 1 times ace 2, which is 0.5917%. Now what we're going to do is we're going to talk about dependent events without replacement. Suppose 2 cards are drawn from a standard deck of cards without replacement. What is the probability that both cards are diamonds? So probability of diamond 1 is 13 divided by 52 because there's 13 diamonds in a deck of cards. Probability of diamond 2 is 12 divided by 51, and the reason why is because there's no replacement. There's no replacement. So 13 minus 1 is 12, and 52 minus 1 is 51. So it's 23.5%. And the probability of both diamonds is diamond 1 times diamond 2, which is 5.88%. The next question we have is dependent variable without replacement. So you have a small candy-coated chocolates come in 5 colors: brown, red, yellow, green, and tan. In an assorted package of 20 candies, the distribution of the colors is as follows: brown is 8, red is 2, yellow is 4, green is 4, and tan is 2. If Sally selects one candy at random and then a second without replacement, what is the probability that both candies will be given? Brown is, and then so we define the variables. So brown is 8, red is 2, yellow is 4, green is 4, tan is 2. Total candies is 20 because it's a summation of the values of the colors. A probability of pulling a green is going to be green divided by total candies, so that's going to be 20%. Probability green 2 is going to be green minus 1, so that's going to be 3, divided by 20 minus 1, which is 19. So that's going to be 15.78%. And then because you haven't replaced the piece of candy that was pulled out. And so that's why you have 4 minus 1 and 20 minus 1. Probability of both green is green 1 times green 2 is 3.1579%. The next question we have is dependent event without replacement. It says, suppose 2 cards are drawn from a standard deck without replacement. What is the probability that both cards are clubs or both cards are from a red suit? So now we have an or question. And so whenever you have an or question, you don't you don't multiply the values, you add the values. So we'll go ahead and go through this. Probability of clubs 1 is 25% because it's 13 divided by 52. Probability of clubs 2 is going to be 12 over 51 because it's going to be clubs, it's going to be 13 minus 1 and 52 minus 1. So it's going to be 23.5%. Probability of red 1 is going to be 50% because it's going to be 26 divided by 52. Probability of red 2 is going to be 25 divided by 51, which is 49%. So it's going to be 26 minus 1 divided by 52 minus 1 because the card that has initially been drawn has not been replaced. Probability of both clubs is going to be 5.8824% because it's going to be club 1 times club 2. Probability of both reds is going to be red 1 times red 2. So it's going to be 24.58%. And probability of both reds or probability of both clubs or reds is going to be both clubs plus both reds. It's going to be 30.39%. So you notice that like whenever you see the or, it's an addition. And whenever you see the add, and it's a multiplication. The next question we have is dependent events without replacement. 3 cards are chosen at random from a deck of 52 cards without replacement. Find the probability of choosing a queen, jack, and ace in that order. So the probability of choosing a queen is going to be 4 over 52 because you have 4 queens in a deck of cards. Probability of choosing a jack is going to be 4 over 51 because you have to, the cards haven't been replaced, so 52 minus 1 is 51. And so that's going to be 7.8%. Probability of pulling an ace is going to be 4 over 50 because the previous card hadn't been replaced. So it's going to be 51 minus 1 is going to be 50. So a probability of queen, jack, and ace in that order is going to be queen times jack times 8. So it's going to be 0.83%. So that's very low probability. So the next question we have is a dependent event. Without replacement. 2 cards are chosen from a standard deck of cards without replacement. What is the probability that both cards are queens? So the probability of the first queen is 4 divided by 52 because there's 4 queens in a deck of cards. Probability of queen 2 is 3 divided by 51 because you take out 1 queen because you pulled the first queen, so you take out 1 queen. And then you take out 1 from the deck, so that's going to be 3 divided by 51. And the probability of both queens is queen 1 times queen 2, which is 4.525%. So we have another question. It's a dependent event without replacement. A basket contains 3 oranges and 4 apples. A boy chooses one at random and then, without replacing it, chooses another. Find the probability that both fruits are oranges. So the probability of the first orange being pulled is 3 times 3 divided by 7, because 3 is the number of oranges and 7 is the total number of fruits. So that's 42.85%. The probability of pulling an orange the second time is going to be 3 minus 1 equals 2, and then 7 minus 1 equals 6. So that's 2 divided by 6. And then so probability of both oranges is orange 1 times orange 2 is 14.2857%. So now we have the last question, which is a dependent event without replacement. And it's a true or false question, and the answer is true, but we're going to go ahead and go through the code anyway. A bag contains 10 green marbles and 5 yellow marbles. A boy picks a marble at random, and without replacing it, he picks another marble from the bag. What is the probability that the marbles are green? Is 3 divided by 7. And so that's a true statement, but we're going to go through it anyway. So the green one is 10 divided by 15, because you have 10 green marbles and a total of 15 marbles. So that's 66.67%. And then for the second green marble, so you've got 10 minus 1 because the marble wasn't replaced. So that's 9. And 15 minus 1 is 14. So you've got 9 divided by 14 is 64.28%. And then you've got both green marbles is green 1 times green 2, so that's 42.8571%. And so that concludes this list of questions where we've gone over the code for independent and without replacement, independent with replacement and dependent without replacement probabilities. So we've gone through quite a few questions to give you an idea of how to do it. So that concludes this video, and that concludes all the questions that we've gone over. So if you like my video, please like and subscribe. And thank you very much for watching this video. I will be making some more videos soon on data science. So watch this space.